Hi everyone, and welcome back to Newegg TV. My name is Paul, and today we are going to be taking a quick look at the Crucial M4 SSD. This is a third generation SSD brought to us by Crucial. We're going to do a quick unboxing to see what comes in the box, go over some of the specs, and also run through some light benchmarks. So let's get started. So first off, a quick look at what comes in the box. You'll find that it is pretty simple. All we have is a warranty and installation instruction booklet, as well as the SSD itself. This is opened because I've already run a few benchmarks on it. But there you have it. We have the 256GB version of the M4, and there's a look at the drive itself. This drive, once again, is manufactured by Crucial. Now, Crucial is the consumer arm of Micron, and if you're wondering why this is not called the real SSD, well, Micron has assumed the real SSD moniker. So Micron will now be making a real SSD C400, which is essentially the same drive as this. This is the Crucial M4. So if you're looking at both, just bear in mind that physically the drive, Crucial M4 and Micron real SSD C400 are the same exact drive. And just to get specific here, the model number for this one is CT256M4SSD2. Capacity is 256 gigabytes. The connection here at the back is serial ATA revision 3, so you can that has a maximum throughput of 6 gigabits per second. And then the formatting capacity, as we all know, when you format a drive, you don't get the capacity that you see on the box. You get a binary capacity, and that is 238.4 gigabytes. Binary gigabytes, I should say. As far as the out-of-the-box ratings, this drive is intended to reach sequential read speeds of up to 415 megabytes per second, sequential write speeds of up to 260 megabytes per second, and a few more details about what's inside. The controller that they're using is a Marvell 9174, specifically the 88SS9174 BLD2 version of that controller, and the NAND flash memory in here is MLC 25 nanometer. 3000 program erase cycles seems like a little bit on the low side to you. Bear in mind that there are wear level algorithms that spread read and writes across all of the NAND flash on the drive, so you can expect at least 5 to 6 years of life out of this drive under normal operating system conditions. So now that we've gone over the out-of-the-box specifications for this SSD, I had a chance to plug it into our test bed and run a few quick benchmarks using Crystal Disk Mark as well as ASSSD. So let's take a look at those results. So first off, this is Crystal Disk Mark version 3.0.1. It just runs a sequence of 300 megabyte tests on the drive. We can see our read column here and our write column here. For reads, we got an average of 357.7 megabytes per second. Sequential reads for writes, we got 226.2. Moving down to the 512K block, we got 317.5 on the reads, and that's megabytes per second, and 226.5 megabytes per second on the writes. For our 4K block size, we got 23.13 reads and 78.63 writes. Finally, for our 4K QDepth32 tests, we got 169.8 for the reads and 165.1. And if we can scroll down here to the lower section, these are the same results, but one thing we want to point out for SSDs is input-output operations per second, also known as IOPS, and that's down here on the right. And we see that with our random reads, writes, both with QDepth1 and QDepth32, we jump from 5,000 to 20,000 random reads and random writes. And finally, for QDepth32 on the random reads, we got 41,463, and for random writes, QDepth32, we got 40,296. And those are some pretty impressive numbers. The second SSD benchmark we ran is ASSSD, which is an SSD-specific benchmark. Here we can see pretty comparable numbers to what we saw with Crystal Disk Mark as far as our sequential reads and writes, as well as our 4K reads and writes. 4K 64-threaded reads and writes as well. We have some numbers there, 161.19 megabytes per second for reads, 143.51 megabytes per second for writes. Our overall scores for ASSSD, 218 for reads, 228 for writes, and 558 overall. One last thing to point out is our access times. We can see 0.058 milliseconds for read and 0.278 milliseconds for writes. That's just another example of why SSDs are so incredibly fast when compared to mechanical hard drives. Their access times are almost negligible because there are no moving parts. And that pretty much wraps it up for our unboxing overview and a couple quick benchmarks for the Crucial M4 SSD. This is once again one of the first Generation 3 SSDs we've seen based on 25 nanometer NAND flash memory. For Newegg TV, my name is Paul. We hope you've enjoyed this video, and we'll see you next time on Newegg TV.